Hi, and welcome back. Today we're going to learn about the sine law and how to solve a triangle that is not a right degree triangle. So a right-hand degree triangle has a 90 degrees in one corner. But what happens if there's not? Let's take a look. All right, for this triangle, what we're going to do is we're going to label some sides. Let's say that we have this side is 22 and this side is 30. And we know that the angle in this corner is 112. How can we figure out what this angle is? That's where we're going to use the law of sine. So the law of sine says that if I take the sine of an angle, and the only angle I know right now is 112, and I divide that by the side length that is opposite, so in this case, 30, I set that equal to the sine of another angle. In this case, I don't know what this is. This can be our corner. Let's just say that's corner A. Then opposite that corner A is the side length of 22. So notice again, it is the sine of an angle over the opposite side equals the sine of an angle over its opposite side. When I know 3 out of the 4 values, now I can cross multiply and divide. That means I'm going to look for the 2 values. I'm going to look for those 2 values that I know are diagonal from each other, and I can multiply these 2 together. I could not multiply 30 times sine A because I don't know what A is, but I can multiply these 2. Once I've multiplied those 2, I'm going to divide by what's left. So take a moment to try that on your calculator. So in your calculator, whether you start with the sine of 112 or you start with 22, you're going to multiply those together. When you do that, you should get an answer of 20.398. Divide that by 30, and your final answer becomes 0.679. Remember, that is the sine of A, 0.6799, and so forth. But that doesn't sound like a degree, does it? So we need to turn this decimal into a degree. And how we do that is by using that second function. So we want to hit that second function button and then the sign to get that little -1. And then I can put in the 0.67999 or whatever it is there. So let's go ahead and second function sign that 0.679. And I am getting 42.7655 degrees. Let's round it to the nearest degree, 43 degrees. All right, so we have found A in this corner here to be 43 degrees. What's this third angle? Once again, we could do the law of sine. But there's a shortcut because remember, a triangle has to add to 180. So if I wanted to solve this triangle, I can simply put in what is 180 minus the 43 degrees that we just found, minus the 112 that we were given when we started. And what do we get? You got it. We get 25 degrees. Remember the symbol for degrees is that little circle thing. All right, now can we solve this triangle for the side over here? Absolutely. Let's set up the law of sine again. So we're going to do the sine of an angle. And because I'm finding x, I need to make sure I'm including the angle that's opposite the side that I want. So it's the sine of 25 over x equals, now I have choices. I can use the sine of 43 over 22, or I can use the sine of 112 over 30. It does not matter. It will give us the same answer. I'm going to go with the sine of 112 over 30. Once again, we are going to look for the 2 values that I know diagonally. I can't multiply x times the sine of 112 because I don't know what x is. That's what we're trying to figure out. But I can multiply Oh, I did it again. Let's highlight, not cross it out. I'm going to multiply the sine of 25 times the sine of 30. Those are the two values that I know diagonally. Once I've multiplied those, I will then divide by the leftover. So go ahead and take a moment to multiply those two and then divide by the sine of 112. What does x equal? Sine of 25 times 30 divided by the sine of 112. If you got the same as me, you're correct. Did you get 13.67? Wonderful. All right, we have found that missing side. Notice I did not need to do anything else. I did not need to hit the second function because this was a side length. Side lengths do not need a second function. Only when we are finding a degree do we need to change that decimal into a degree. So that is how we use the law of sine. Always remember, angle over the opposite side. Would it have mattered if I did it this way and did x over the sine of 25 is equal to 30 over the sine of 112? No, it does not, because you will once again notice that the stuff that I'm multiplying does not change. They are still diagonal. I would still be dividing by the sine of 112. As long as you have a side length paired with its an angle paired with its opposite side, it doesn't matter which one goes on top. But you do need to follow the same format. So if you're putting sides on the top, you always need a side length on the top. If you're putting degrees on the top, you should always have the sign of the degree on the top. You can't start switching so that they are no longer equal fractions. And that is it for the law of sine. I hope that helped clear things up.